OK, this thing is on. Can everyone hear me? Cool. OK, so yeah, I'm Anna. I am on the Node.js Technical Steering Committee, which is basically the group of people that makes decisions if something is contentious within Node.js core. And I've been active as a contributor since December 2015. And before I actually start talking about workers, I want to show you my first contribution to Node. That is, if I can get the slides to work. This. OK. Cool. So before I was a Node core contributor, I was working on a project, and I had some code that, I mean, it didn't look exactly like this, but it essentially called setTimeout with like arguments that didn't make any sense at all. And I think if you like have a copy of Node 4 or something, you can actually try to run this, and you're going to get something like this. And what you see is that the stack trace that you get, you see that it actually happens in the onTimeout function. So it actually only errors once the 1 second has passed, which like makes it absolutely useless for figuring out where these invalid arguments came from. And so because I thought that when I encountered this, that the easiest way might actually be to just patch Node and add type checking to this. And this is what I came up with. It's not a complicated thing, right? Yeah, I did that. I tried that. It helped me figure out where my bug was. And what I did then was to turn this into a patch, submit it to Node core. I mean, obviously, this wasn't the whole patch. I had to add tests and documentation. But yeah, generally, this is one example of how you can get a feature into Node core or your patch. And I like this example because it shows like what open source is about, right? It is about if you have a problem and you have a solution, you can make it available for everyone. Whether that is a PR to some other project or you publish a module of your own, do it. It's great. OK, back to workers. OK, no, one thing more. The reason I'm giving talks on this is that before I became a Node core contributor, I didn't really know a lot of what was going on within that core community, which is like a bit of an in-group. And I didn't know much about what happened, except maybe stuff that I had read about IO.js. But that was also always like always second-hand knowledge at best. And I suspect that a lot of people around the ecosystem still don't really know what we are actually doing. I mean, you might have heard about workers being added to Node, but you don't really know anything about the story behind that. And because like there's a whole hidden world there. Like the Node.js organization, GitHub, has like 150 repos or something like that. That is why I want to talk about these things. OK, now really back to workers. OK, so this is feedback that I got on this weekend. And I'm just going to read the first parts because, like, OK, so 50% speed up for my algorithm, workers rock. Loops needed about 5 milliseconds before workers. Now they need about 2 milliseconds on a 6-core machine. I'm using channels for messaging and promises to gather the results. And this kind of comment is exactly what you want to hear, right? If you like something, tell the people who made it, because it makes it feel like this feature is actually useful. OK, taking one step back, so like to understand what problem workers are actually solving. So a typical Node.js process is like this stack of things, which is, okay, you have one process. In that process, you have one thread, and it's marked with an asterisk because that's not true, but it's true enough. It is true in the sense that you, as a user, cannot access anything else that happens beside the one thread on which your code runs. Well, you have one event loop, which typically makes sense. You want to have one event loop per thread in any application most of the time. You have one JS engine instance, so one JavaScript runtime where all your code lives and runs, and one Node.js instance that is built on top of all of that. And so the issue with this is that when you only have one piece of code being able to run at any time, well, it means that whenever your code runs, nothing else can run at the same time. It also makes life a bit easier because, if you've ever tried parallel programming, especially like in languages other than JavaScript, where threads have like a different kind of importance, you know that it's tricky because you're going to run into all kinds of race conditions and deadlocks, and it's just like not fun at all. You can obviously still have race conditions with a node because we have this whole async I/O thing. So yeah, multi-threading is actually making that worse. Okay, but the problem with this one-thread approach is that, okay, your code runs, nothing else can happen at the same time. That means if you have some CPU-intensive code, you cannot really do anything else at the same time, and it might increase the latency of your application. Because what you really don't want to do is to block the event loop from progressing, because that is the exact thing that introduces latency into your applications. You want to be able to continue doing things. So what you would typically do currently is to start up multiple processes. That is a good solution a lot of the time. A lot of the people in this room who have used Node in production have probably at least tried using child processes or the cluster API or something like that. But that isn't perfect. It's good enough for a lot of things, but if you actually have some smaller scale problems where you want to have the different things that run in parallel, if you want to have them interacting more closely, that gets tricky because you cannot share memory between those things, cannot share JS objects between those things. So in the case of child processes, we, at least Node.js currently, only supports JSON, so that also limits you in what kinds of things you can share between processes. It also has some advantages, it is a pretty good advantage that if one process has an uncaught exception or crashes for some reason, that doesn't affect the others in any way. You can just start up a new one. And you have completely identical APIs in each of the different node processes because on some level they are all identical. But there's so another way to approach this, which is a more typical pattern outside of the Node.js world, is to use multiple threads. And basically you duplicate everything that is built on top of that. So you still have one process, but you have multiple things that run in parallel and that can actually use the multiple CPUs that your machine typically has. And on each thread, you still have one JS engine instance, so that's V8. You still have one event loop, which is libuv here. And on top of that, you have one Node.js instance, whatever exactly that means, it's well, it is well defined, but it's hard to explain in a couple of words what that means. And you have your code running on top of that and using the Node.js APIs. And so the idea how one would, like the easiest way to go about that is to say, okay, so Node.js is a C++ library, basically. And you can, like in theory, we want to support people who want to embed Node into their applications so that people who write other C++ code can actually go and use Node for running JavaScript as part of their C++ applications. In theory, that is like easy enough. In practice, it's well, it's no. I mean, there are people who do it, like Electron, for example, but they also have a hard time with that because, yeah, we're not great at supporting that just yet. It is definitely something that I am working on, and that so what I want to have in the future is a good API for actually embedding Node.js into other applications, and maybe write a guide on how to do that. But we're definitely not there yet. But this also was a problem when working on workers. It's like some of the problems, or a lot of the problems are shared between this problem and the workers implementation. So what you definitely don't want to have is global state that is per process, because, well, you definitely get into tricky issues when you want to access the same global state from different threads that are running at the same time. And because we didn't support multi-threading until very recently, we had a lot of global state because sometimes that was just the easiest solution for whatever somebody was working on. Node.js also did not clean up resources on exit. And what I mean with resources is it didn't close file handles or network sockets. It didn't free any memory when the process was being exited. And it didn't have to, because when all you're running is one process and one Node.js instance within that, you don't have to care about that. You can just shut down the process, exit it, and let the operating system clean up the rest. Embedders don't like that because they might want to start up multiple Node.js instances, and they don't want to have each and every one leaking memory. Workers, it's for the same reason. When a thread exits, and now you can actually be in this situation that a worker thread exits, and you still have other threads running. You don't want to have its resources still lying around. So these were tricky things here. There was also some prior attempts at solving this kind of problem. So you might actually have heard about this if you have been around for a long time. And you can look at the date here. It says March 15, 2015. That was the first time a PR was opened against Node.js, or at that time it was io.js. And these PRs by Petka, they actually mostly just stalled out. And a lot of that was because there weren't actually enough reviewers around for this to happen. Which is I think that's kind of interesting. Because well, for one, it doesn't happen a lot anymore. But also, it was even if it was io.js, it was still a big project with a lot of people who could look at it. There's also a implementation by Audrey Tang, who's the digital minister of Taiwan, by the way. And well, she wrote something that is closer to the web workers API, so where you actually do not have the full Node.js API available, but rather just enough to run things in parallel. So basically, just run JS code. Okay, so just about a year ago, there was this fork of Node.js, which you also might have heard about, which is also kind of pronounced IO. So that is slightly confusing, but that was partially intentional. And yeah, so this fork happened because people were unhappy with the Node.js leadership. And there's a whole story on that I'm not going to go into. But as part of that, I and a couple other people worked on a workers implementation because that was a feature of Node.js that was requested a lot. But that didn't really happen until then. And I mean, it was not one of these issues that were blocked by the Node.js leadership in any way. It was just something, OK, we have a fresh start. We don't have to stick to the rules as much as we did before. So we can just go ahead and do things. So we actually worked out a working workers implementation. And this is, I think this happened in May and June, yeah. OK, so I ported all that over to Node.js. And well, a lot of people were very excited about this. One person was not. But yeah, so we implemented an experimental workers implementation. I'm going to go into what that exactly means in a bit. You may also want to note, if you can see this down here, so experimental, it is experimental to the degree that we're not actually set on keeping the current module name around indefinitely. But yeah, this happened. OK, so what were the major issues with it? So one thing, Windows support. And this is not actually because Windows is a bad operating system. It is mostly because the libuv code for supporting Windows, which is a completely different set of the code that we have in libuv for Unix. Well, it works, but it worked good enough, right? And we had some issues getting that to work, supporting these shutdown things on process end or on worker exit kind of situations, like when you have a pipe on Windows, it wouldn't completely clean up until something specific happened. So that was definitely a tricky thing. Another thing was, so on NPM, both the worker and workers module names were taken. And back when we first started working on this in IO.js, that was not the case. But in the meantime, until we ported this over to Node, well, somebody else took it. And that was actually the first time that we reached out to an NPM module author and said, hey, could we have this name? He's like, it would be cool to have it. And that library, it still has 70 downloads per month or something like that. And this is the first time that we actually encountered backlash with that. It was not an issue with HTTP2 or other things that we had previously taken. I don't know. There's not a long list of that. It might be 2 or 3 names. But yeah, that was kind of surprising, actually. But yeah, we had to figure something out. And so one thing that was discussed and that might still happen in the future, we haven't reached a decision on that, is that we may prefix new module names with @Node.js. I'm personally not a fan of that, but there are definitely valid points on both sides. Surprisingly, there weren't as many issues with getting reviewers, or at least getting approvals for the PR. That was partially because in the work in IO.js, we already had other core collaborators who figured this out together with me. And so they had already seen the code and reviewed it and talked it through. But still, compared to Petka's approach, or his, sadly, non-success, this was cool. And yeah, the result is that we have workers in Node 10. And OK, so I have this the schema up here again. And we basically have everything duplicated except the process itself. And so we still have separate JS instances, separate event loops. And what that means is that it's actually pretty easy to just provide the whole Node.js API for everything. So that means require works. It also means that we did not quite go for the web worker API because we already support a different set of features and a more complete one, definitely. Most core APIs works. So like there are some exceptions, like you cannot change some things from a worker, like the current working directory or environment variables, or just like global state for the process. That does not quite work for good reasons, because like you don't want to have multiple threads changing the same attributes of the process at the same time. So for communicating between these instances, we have something a lot closer to the web. So we have message port and message channel instances. This is also what workers and the browsers use, or at least they could use that. We have that implemented now. You can transfer array buffers, and you can share shared array buffers. And this is really cool, because this means that you can actually share and move memory between these different threads, which is something that you completely couldn't do before. And this is important for addressing the use case of CPU-intensive applications where you want to have close interaction between the different threads. We have some ways to provide startup data to workers. That is kind of contentious, because it's something that there was a PR to remove that a while ago. It's closed now. But I can definitely still see the point for removing it, because it's something that is not easily like polyfillable if you're working on code that works both in the browser and on Node.js. I don't see it as a huge issue, because like if you want to have that kind of code, you can just not use it. But yeah, one thing that you should definitely take care of if you want to try this, or if you have tried it, is that native add-ons are usually not written in a way that that plays well with workers. So you should definitely check your code, or reach out to add-on code authors, review their code for thread safety, and for cleaning up resources when when it is being unloaded. Yeah. Okay, so here's a code example. And I'm sorry if this is like a bit much code for one slide, but okay, so the first thing, we require the module name worker underscore threads. It's sadly not workers or worker, but it's close enough. So there's a worker class. We can create a new worker with the new worker constructor. So typically, as the first argument to that constructor, you would pass in a file name, because it would take even more place to actually have different files up here. So I use the alternative way to do this, which is to pass in a string, just some JavaScript code, and use eval true. So it essentially means this is not a file name. This is just some code that you should run. Inside that worker, inside that different thread, we take the parent part, which is it is the communication channel to the parent thread. And so if you have ever used web workers, you know that communication with the parent thread that works over global variables on the global object, on the window object inside the worker. But in Node.js, we're kind of careful about adding new globals. So we went with this. Once we receive a message and we use the standard Node.js event style here, it's just .on and then the event name. You can also use onMessage like you would in browsers. Okay, once there is a message, respond with post message. Okay, so outside the worker, once you get a message back, you console.log it, and then you send the first one, which is, okay, you send ping inside the worker, it receives the message, it replies, and then it prints it out when the main thread receives the message back. This is a slightly more complex example, and I picked it because it shows how to use, like how to actually share memory. And this is obviously not an example where that actually makes sense in a real-world application, but it might give an idea. So we create typed arrays of integers, so an integer 32 array, but we don't create it like we usually would. We create it from a shared array buffer, which is a non-default kind of array buffer, but that is actually shareable between different workers. So that is cool. We initialize it with some data. We create a worker, which, well, again, it listens on a message. Oh, it does not, but right, because we're using worker data for passing the initial data for it. It computes the prime factorization of that number 2016. The exact code of these lines isn't important. And once it is done, it actually uses an API that you may or may not have heard of. It's Atomics. It is a built-in JavaScript thing, so nothing that we as Node.js people made. And well, it is something that is close to mutexes and condition variables and stuff like that in C or C++ or other languages. And well, atomics.notify wakes up the main thread, which is probably at this call here, the atomics.wait call, which is actually a completely blocking call in JavaScript, which is something kind of unusual. Yeah, you don't usually have completely blocking JavaScript code. Okay, this is currently experimental, which means that if we find it necessary, we can do breaking changes at any time. Of course, we don't try to do that. We're definitely looking for feedback because we haven't gotten a whole bunch of that so far. So if you have any real-world usage or even just something that you experimented with and you have something to say about that, even if it's just like one quick sentence or something like that, I'm really happy to hear about that. Things that are happening right now is we're adding support for the weblogs API, which is, well, you can look it up, but it's a nicer way of controlling access to resources in a shared, in a multi-threaded environment. DevTools support is not quite yet there, but we're really, really close. Terminating a worker, which is also available as an API, that is kind of experimental within experimental, which means it's not working consistently quite yet, and that has to do with the way that this kind of termination works. It's essentially, so the way that V8 implements this is it basically uses an uncatchable exception. And so when you call .terminate on a worker, that means that any code that is currently running can fail. So, and because you don't have control over what code exactly is running, any code can fail, and Node.js is just not, well, it hasn't been created with supporting that in mind. Something that hopefully gets implemented is passing around native handles. So like, for example, network sockets, like you might be used from it for the cluster API. I want to implement something that is kind of like deadlock detection. maybe have a bit more isolation between workers. Like this is, at least currently, but it's definitely not something that you should use to run untrusted code. Other people, in particular Alibaba and Microsoft, have developed similar things, and they actually have gone a step further and enabled sharing actual JavaScript objects between the different threads, and not just some like typed arrays of memory, which is definitely really, really cool, but requires engine modifications. So it's not just something that Node.js can do on its own. This does not make everything magically faster. It doesn't make sense to use this for parallelizing I/O, because Node.js already does that on its own, and it's pretty good at that. And okay, using workers for that is just not going to help. Spawning workers is also not exactly cheap, because we still have to boot up a whole Node.js instance every time. And while we're working on improving startup performance, you probably should still stick to using worker pools if you have a lot of short-running tasks that you want to to outsource into different threads. I'm going to skip this one. OK, so heads up. Just so you know where we're currently at with the releases, and I like to include this in every talk that I give. OK, so Node 6 is in maintenance mode, supported until April. You probably should be looking into starting to upgrade if you're still using that. And Node 8 is supported until December next year, so that's still quite a while. Node 10 is supported until April 2021, so that's quite a while. And it will become LTS, so long-term support, which is what we recommend people use for production in October. And we will also release Node 11 in that time. If you have any questions, I'm here. This is a picture from my bathroom this weekend. I'm on Twitter. I'm going to post the slides there in a moment. And yeah, this is it.